Hi guys, it's Miss Perry again. All right, here we go with Newton's second law of motion. And the second law of motion talks about acceleration. Okay, so the force required to accelerate an object at a certain rate is equal to the object's mass times the acceleration. Okay, so let's break that down just a little bit. The force applied to an object is directly proportional to its acceleration. And the unit of measure for force is newtons. So let's look at an example. If you're throwing a ball, with football, baseball, if you're throwing a ball, you're throwing it harder and it goes further or it goes faster. Okay, if you throw it with less force, then it won't go as far or as fast. And that's all Newton's second law is. The more force you have, the faster the object will accelerate. Okay, also we talk about not just the force, but the mass. An object that is heavier requires more force to move. So in my example, you have a wagon with one person in it or a wagon with four people in it. Now, if you have a lighter weight, like the wagon with the one person, it's going to be easier to pull. Okay, if you have a lot more weight, it's going to be harder to pull. So it's pretty much common sense. If you have something heavy, it's going to require more force to make it move. Okay, so this has an equation. Force is equal to mass times acceleration. And I'm giving you the triangle right here so that you can move it around in case you need to find something besides force. And you know how to do this. We've talked about it. And remember that force is measured in newtons. Okay, so let's look at an example. And these are from your book. So if you want to take a look at those later. The first example, how much force is required to accelerate an empty grocery cart with a mass of 10 kilograms at a rate of 2 meters per second squared? Remember, the meters per second squared is the unit for acceleration. Okay, you're not squaring anything. That's just the unit. Okay, so we'll look at our givens. Your mass is 10 kilograms and acceleration is 2 meters per second squared. And that's the equation we're going to use. So then we're just going to plug in and chug. You've got 10 times 2, and that's 20 newtons. So that's how much force is required to push an empty grocery cart. Okay, so let's look at the second one. How much force is required to accelerate a full grocery cart with a mass of 60 kilograms at a rate of 2 meters per second squared? Okay, so we still have the same acceleration, but we have a different mass. The mass is greater. So those are our givens. Same equation. And there we're going to plug and chug. So you've got 60 kilograms times 2 meters per second squared, and that's 120 newtons. Okay? So you're going to look at the practice worksheet on RenWeb. Skip problem number 4. That's not something we've talked about yet. There are other formulas on there, but you already know how to do that. All the formulas are at the top of the page. Now let's look at the first one. And if you don't have it downloaded yet, you can stop right here and then get it downloaded, and then you can do it with me. Okay, so the first one is to calculate the acceleration of a 500 kilogram car that has 5,000 newtons of net force exerted on it by the engine. Okay, so we want to calculate acceleration this time. So if you're looking at your triangle over here, acceleration is force over mass. And those are my givens, and that's my equation. Okay, and I use this triangle over here to figure out how to calculate acceleration. Okay, so you're just plugging and chugging 5,000 divided by 500. and your acceleration is in meters per second squared. And so you're going to end up with 10 meters per second squared. And that's your answer. Okay, so go ahead and try those. Contact me, email, or remind, and let me know if you have questions about it. And then after you get a chance to work on it, then I'll do a video and go through it with you. Okay, take care. Bye.